Today we will cover attributes, methods, and operations on a series. Okay, in yesterday's class, I missed just one more thing. We have covered accessing single element and multiple elements from a series using index and position, but we haven't covered slicing. See, if we have multiple elements in a list, here I have a list with three elements in it, right? I can slice it like I can get a range of elements. Like if I want to get element from position 2 and position 3, I can do this. Let me add more elements to it. E- Here we can retrieve continuous elements from the series back, from a list back. We can do the same with series too, but since data in the series can be accessed using either an index or either using position, we have two ways to slice a series. The first way is slicing using labels. Mm. Okay, series 1 and series 2, right? Let me create a very long series, pd dot SCRA series, list range 10. Let me also attach an index to it. List range 10. Here I created a very lengthy series with elements from 0 with, let me print it. See, here I created a very lengthy series with data as 0, 1, 2, 3, and up to 9, and the index is also the same 0 to 9. Now, if I want to retrieve multiple elements back from the series, I can do it either using labels or either using position, right? Now, here, let's see. 2 colon 3. No, this is hard to understand. So let me give an different index to it. B, C, D, E, F, G, H, I, J, K, L, 4, 4, yes. Yeah. Look at this series. Here the data is from 0 to 9, but the index is A, B, C, D, and so on, right? If I want to retrieve from, let's say, E to H, E colon H. See, here it is retrieving me back all the elements falling from the label E to label H. This is more, this is exactly the same as this tool, LOC E colon H. See, both either using .loc or without using .loc, it will behave the same, just like how we could retrieve using a single value or multiple values. On my left side, you can see it. This is how we can retrieve multiple values by mentioning their indexes. This is how we can retrieve. Where is this setting up data? Right. Yeah. This is how we can retrieve single value using index. And slicing, where is the slicing? Yes, this is how you can slice it using index. Now we can even slice it using position. If you see, when I slice it using index, it will return everything falling in between label E and H, including H, C, E, F, G, H. But if I do the same with position, what is the position of E? Let's say 4, right? 4 to H, what is H? 7. It will not return the value at 7. E of G. it will only return positions from 4, 5, and 6, just like a list. Slicing using positions is the same like a list. When you slice a list, it will not return the final or the end position, right? The same is true even for a series. When you are slicing a series using positions, then it will only return from the starting position to the final position minus one to position. Here I asked it to slice from position 4 to position 7. So it should have retrieved E, F, G, and H. But since H, the seventh is the last one, it ignored H and just returned E, F, G. So there are three different ways to retrieve data back from an series. A single element, a multiple elements. Multiple elements, you can either mention the exact positions using by mentioning the multiple positions as a list. Where is this? As a list like this, or you can slice it. Slicing can also be done using index and positions. So in total 3 into 2, 6 different combinations to retrieve data back from a series. And now this sliced portion, we can overwrite all the data that we get in the slice. Here I am slicing 4 to 7, right? We can just override it, just like how we did for multiple elements accessing in previous class too. Let me write how many, there are three elements in here, right? Let me dd, dd, and dd. Since I am retrieving three elements back, I assigned it a new list with only three elements. In a way, asking it to override the retrieved values. Now let me print this series again. The series dot location dd 4 and 7. Loss is set item error. Okay, since they are integers 11, 12, 13. Yes. Okay. Si- Since it is a list of integers, the data type is set to integer. I tried to assign strings and it raised an error. But when I tried to set integers, it doesn't raise any C. Here, the retrieved portion is EFG, right? And the new values have been overwritten on the old data. You can do the same with when slicing using index 2. Here, you can 1, 1, 1, 1, 1, 1, 1, 1. See, accessing data and overwriting data are the same. If you assign if you access a single element or multiple elements, then if you just put an assignment operator there and write the list with the same number of elements you retrieved back, it will just overwrite the retrieved data from the series. This behavior is identical to even for a list too. When you get a single element from a list or slice and list, you can give it a new value and assign it with a new list with the same number of elements as the retrieved one, and the values will be automatically assigned. Okay. Are there any doubts related to slicing, accessing, and retrieving data from the series? Sorry, accessing and setting data in a series.
Yeah, no.
Mm, fine. If you see, while accessing, you can even use these notations. I think I have covered over this in si- my list notes too. If you don't mention the starting position, it defaults to 0. If you don't mention the ending position, it will default to n minus 1. And you can even use negative positions while slicing using positions in a series too. You can ignore it. If you were able to comprehend it, then fine. If not, just ignore them. Accessing data using label slicing, position slicing, fine. Now, accessing data using conditions. Let's say we have a list of we have a series of numbers or series of strings. In fact, it can be any series, a series containing some homogeneous data. And you wanted to retrieve back only those elements that satisfy a specific condition. Like you want to iterate over each element and see for yourself that if this element is greater than this value or less than this value or equal to this value, I want to retrieve this element back. Something like that. In such case, if it were a regular list storing the data, we would have to iterate over it and check the condition on each element. And then if it satisfies, we will store it back in a new list, right? But in case of a series, if you have stored that data in the form of a series, there is no need. You can directly mention the condition and retrieve back all the elements that satisfy that condition. Here, since our series here is storing a list of integers, I can write an arithmetic relation like this. Here, my meaning is only fetch back those elements from series whose value is greater than 5. Let me make it 5. See, this is the actual data in the series. Mm, mm, yes. This is the actual data in the series, but when I did this series 5, series greater than 5, and then I passed it inside another series, here it retrieved only those values that satisfied this condition. Is this clear? Hmm.
Yeah.
This is more or less equivalent to even you can place .loc in here too. It will behave the same way. But Mhm. If you want to do the same thing with position based filtering, this is quite hard to do. Ignore it. You cannot conditionally filter something using positions directly. You can do it theoretically using this, but it doesn't make any sense. Is this any readable on my left side? Here you can understand that retrieve back all the elements from series which are greater than 50. I think you can understand these two lines, but you cannot understand this line. So for now, ignore that. If you want to conditionally retrieve elements from a series, then you should directly use dot lock or not use any dot. Open parenthesis, write your condition and retrieve back the. And by the way, here you can even cascade different conditions too. Here series 1 greater than 5, right? And series less than 9. What if I wanted to do this? Here I am asking pandas to first series 1 greater than 5, also element less than 9. It will only retrieve back a series whose elements are either greater than 5 or less than 9. See, only 8 satisfied our condition. Why? Let's see. Okay. Greater than 5 is this part and less than 9 is this part, right? This only this. Less than, how much did I write? Less than 9. So 8 is the only element that satisfies greater than 5 and less than 9. So it just returned 5. My intention here is you are not limited to just a simple condition. You can keep on extending this logical operations again and again. And here you can use greater than, less than or equal to, double equal to anything. Good. If you ask me how is this behaving, yesterday I told you that when you operate a series with an another scalar value, you will get back a new series, or we call it broadcasting, right? Let me show it. Series greater than 5. what does this return? See, it will return back a new series with the same index and true or false based on the condition we write. And for series less than 9, it is also true. It So when I operate both of them using AND operation, they are operated based on index. Since they are the same index, same series, here the series SCR and SCR are the same, right? They contain the same value. So the index returned by this value and the index returned by this value is exactly the same. So this operation will never fail. And then they will be operated based on indexes. And since same index, they will become, let me also print it. This is series greater than 5 and this is series less than 9. Since they are the same index, their indexes also will be identical. So when I perform an AND operation between two series with the same indexes, true will be operated a position, false and true. False and true. It will operate something like that. And the returned series will also have the same index as both of them. So when I write a series of booleans and a series containing booleans and with the same index as, oh, this is quite complex. Let me put it this way. Series dot log. If you want to positionally retrieve conditionally retrieve something, all you have to do is mention labels here, right? I can mention A, B, and stuff like that. But when I write a condition, what it does is it will return back an index and a boolean. The index will be the elements. No, ignore this. Just know that if you write a condition, only the elements that satisfy this condition will be returned back. And by the way, you can even assign values to it too. If you know the size of the returned value here, while conditionally retrieving data back from a series, knowing the exact size can be quite hard, right? Here you don't know the size, you cannot guess the size. So you won't find me writing something like this. I will write this only if I know that the size is return size is 1. But if I don't know the return size, I cannot assign a value back to it. But it will still work. Okay, let me make a very huge value here. Right. Okay, okay, okay. Why? Maybe the value got changed to 2. What's wrong? Let me see. What is this returning? Okay, okay, this is returning nothing. So when I try to assign a value, this is failing. Let me. Mm, Okay. Now what does this return? Okay, this returned 3 values. So I can just do this. And let me print it back. See, it got altered. G, H, and I got changed. But this is quite hard. See, unless you exactly know how many values it returns back, you cannot do this. And now the when you are trying to access data back from a series, the if you retrieve a single element, that element will be returned back. But if you retrieve multiple elements by mentioning multiple indexes or multiple positions, or either using slicing, it will return back a new series with those indexes in it. And here is a short table just explaining that. Yes, I think you can understand this feature by now. I told you, right, series can store almost anything in Python. If you store something, an immutable object, another data structure inside a series, and you accessed it using like this, you access it, and then if you try to mutate it like dot update or dot pop something, the original series will also get affected. This is the object referencing that I explained in earlier classes, because the accessed value and the value inside the series are one and only the same. So when you apply methods on the accessed values that change the original object, the even the series will get mutated. So you should be careful. Original series, good. Now setting data in series, we have covered it. And while setting data, I mostly used a list, right? I assigned a list of values to the retrieved data to set the data. But you can even use a tuple of values to assign it. You can even use another series to set data for a retrieved data. Here, let's see. Here I am retrieving ACE, right? Hmm. No broadcasting. Okay, fine. Let's say here I retrieved on my left side, I am retrieving data back from an series, just three elements, A, C, and D. Now I have three options to do it. I can, if I set a scalar value like this number, what happens is this number will be set for all A, C, and E indexes. But if I set a list of elements, then the length of list should match my retrieved elements, and that data will be overwritten on ACE index. That is the second option. I can even use tuple too, just like a list. And my third option is I can assign back a new series. See here. Here I am retrieving indexes A and B and trying to assign a new series over it. My intention is store apple at index B, store bat at index B. This is what my intention is. But this behavior is extremely complex. When you try to assign a series to the retrieved values, there are few rules attached to it. Let me, where did I write it down? Assigning a series using SCR. Yes, assigning a series using lock. Assigning a series, where is iLock? Not lock. Assigning is label based. PD dot series. Where is this? Did I miss? Hmm. Okay, fine. Hmm. Up until now, I told you that .loc and direct using parentheses directly are exactly the same, right? The one and only difference, you will never see this in code too, because you won't be doing this very frequently. The one and only difference is when you retrieve directly using parentheses, or when you retrieve directly using dot lock multiple elements, and then if you assign back values using a series, not a list. When it is a list or a tuple, the behavior will be the same again. The only exception is when you are trying to assign a series to multiple values sliced from a series. Direct parenthesis will assign data based on position. Like here, see, the index is x and y, and the index is a and b. Here it will ignore the index. It will assign based on position. Like apple will be in A, bat will be associated with B. But in case of LOC, it assigns based on labels. If the incoming series doesn't have matching labels with the labels you retrieved, it will attach none to them. So this is the only situation where direct solid brackets and dot loc differ from each other. This is extremely rare, but just know that when you try to assign a series to retrieved data, this will come into picture. Like if you use solid brackets directly, it will assign based on position. And if you use the dot lock, then it will assign based on index. Then the incoming series should have the same labels as the retrieved series labels. Else it will assign none. Okay, let me show it to you. Okay, series A and B. Here I am asking it to retrieve back A and B, right? Now if I try to assign a new series to it, pd dot series uh yeah, triple one, triple two, triple three, and index is let me make the indexes. I will match one index and will give another index mismatched index. See B, where is A? Okay, B is assigned. The value of A, that is triple one, is given to A since it matches, but the B is not assigned any value. Wait, 1, 2, 3, what? Okay, okay, okay. Dot lock, right? See, even I forgot. If I don't use lock, they will be assigned based on position. So it assigned based on position. It ignored the index and gave triple one and triple three. But when I use lock, see, the B got nan because I tried to access A and B from the series and gave it a new series with indexes A and DD. Since A matched, it attached the index A, but DD doesn't match to B, right? There is no value for B in our incoming index. So what happened? It just gave it nan and it just ignored the new indexes. Is this behavior clear or does anyone have doubts? Okay, I am assuming no. This will only come into picture when you try to assign a series to an retrieved data back from a series. Okay, accessing, and we have completed accessing and series. Our conclusions are three ways to access: direct to solid brackets or using dot lock or dot ilock. Dot lock and direct solid brackets are mostly the same. Dot lock and solid brackets take a single index or multiple indexes or a range of indexes, and lock will take a single position or list of positions or a slice of positions. You can retrieve back the data and use it directly, or you can overwrite it with a list containing the same number of elements as the retrieved one. And you can even retrieve back position with a condition, like only retrieve something with this condition. You can write the condition directly inside solid brackets, then it will work just fine. It will return back a new series. That's it. Now assigning, we covered the hard part. Attributes and methods. These are just, as I told, there are so many attributes and methods on series, but here I just organized them into different subsections, so it is easier to remember. In this section, understand the structure. It contains attributes and methods that will help us understand the, uh, let's say you loaded a series from a file and you don't have access to the file. You should infer directly from the series itself. But you might say that I will print it. Printing it is not an option because what if the series contains a million values or million elements? Then just printing it doesn't make sense, right? We have to understand its metadata, like how many elements does it has, how does it index behave, what type of data it contains, and so on. Here is a section that helps us do it without printing it. Length length function. You can directly use a length function on the series and it will print back the total number of elements in the series, which is 10 in our case. And then series dot shape. This is an attribute on every series object. As long as it is a series, you can use dot shape attribute on it. See here it is returning back a tuple with two elements in it. The first element is the length 10. No, a single element, a tuple with a single element, and the first element will be the total number of rows in the series. Good. Then series dot name. I told you that a series has the data, index, position, name, right? By default, index will be 0 to n minus 1 and name will be none, right? If you want to access the name, you can just do dot name. Here it is not printing anything because it is null. Let me use a print over here. See, by default, the name will be none. And the same, the index, I think you will already know this. Series dot index. It will return back a list like object containing the index of the series. If you truly want to make it a list, just wrap list around it. This is more easy and comfortable to work with. And series dot data type. If the series contains homogeneous data, then you can use this attribute dot d type. You got float 64, right? Because it contains C floats. That is why it is showing me float 64. If it contains heterogeneous data, it would have shown me object. And finally, series dot head and series dot tail. Like I said, if a series contains a million elements, we cannot print its entire thing, right? Even if we print it, it will overwhelm our notebook and we cannot make sense of it. Then what if you just want to view a few elements from, just give me a minute. Sorry about that. If you just want to retrieve few top elements, like let's say it has a million elements and you just want to see first five elements, then all you should do is dot head method and you can mention the number, how many elements you want to see from it. Pay attention because most of the attributes and methods that are on series to understand the structure will remain same for data frame 2. Now tail is easy to understand. Just like a head retrieves top five elements from the list, tail will retrieve the last five elements from the list. Here you can mention any custom number too. I think it will raise an error. Yeah, no. I asked it to retrieve 5444 elements from the bottom, but since it has only 10 elements, it is only returning me the 10 elements. Good. If I think if you don't mention any number, by default it will default to 5, I think. Yeah, 5. If you don't mention any number in head or tail, it will return back 5 elements. Good. That's it. You should remember the length, shape. These are easy to remember, right? Shape, name, index, data type, and head and tail. And along with them, length. These are used to understand how the index looks without us having to print it directly. Now, understanding the data. Now you have already understood the shape, but what if you want to understand the data more? Like does it contain strings or does it contain integers? If it is integer, what is its distribution and so on. Here, we have an describe method, and the describe method, what it does is it will directly, if its behavior changes depending on the data type that our series contains. Here, since our series is storing numerical data, it is telling me that the count, it is telling me numerical distribution frequencies. The mean is this much, the standard deviation is this much, the mean is this much, the max value is this much. These numbers doesn't make sense now, so just leave them. These are what we call quartiles, how many numbers are below the mean, like 15. There is only 25 members below the mean and 50% equal to mean, and something like that. What if we have, let's say, I want to show you its behavior in case of series cpd dot series list a b c d e f g h 8. Okay. I showed you describe behavior on an series containing numbers, right? Let's see how it behaves on an series containing strings. See, in case of strings, it is showing me the count 8, total number of elements in the series 8, and unique. It is telling me that out of all these characters, there are 8 unique ones. Here, there are everything is unique, right?
Tarun, I'm not able to hear you.
Sorry about that. Okay, where did we stop? Okay, with the describe, right? Yeah. The data that, oh, yeah, am I audible?
Yes, yes, you are audible.
Yeah.
Describe on string types.
Yes. If let me, okay. Most of the times, a series can contain only numbers, booleans, strings, and date times. You won't see anything other than this. When I meant numbers, integers or floats. These are the only 90% of the cases you will have a series with one of these data types. I mean, all the data in the series will either belong to numbers, booleans, strings, or date types. In case of numbers, it will return us back mean, standard deviation, minimum value, maximum value, and so on. This is very useful to understand the numerical distribution. Whenever we see a series with numbers, we are curious, right? What is the maximum value that it contains? What is the minimum value it contains, and so on. So the describe will print those metrics. But if it contains strings, we are interested in knowing how many strings exist or how many elements exist in the string, then how many of them are unique, how many of them are duplicated, how which string or which string is the most frequent string. We are interested in knowing that those terms, right? So in that case, describe will return us back the count, total number. Then the unique, it is telling us that eight eight elements in this series are unique. What it means is 8 is equal to 8, right? So there are no duplicates in it. And top is the string that is most frequently used. That is and frequency is the number of frequency. Let me write it down. Let me make it triple A, double B, double C, F, F, F. Take a look at how this series looks. See? Okay, no. Series C. See, this is a series with how many elements? 16, right? Here, B are elements inside my series, and now this is confusing. If I use describe, it is telling me that there are 17 elements in your series. 8 of them are unique, and C is the topmost, the most frequently repeated element, and it was repeated 4 times. See how describe is making our data make sense, right? Without this, you understand a data bit less. But with this, at least you know that, okay, these many are unique. This is the most frequent one and so on. And it more or less remains the same for Boolean values too. For Booleans also, I think it will give us the unique top and frequency. It is easy. So the moment you see a series, after understanding its shape, you have to at least once run describe method. Then you can make sense of what it represents, the behavior of data. Series does describe include statistics for all data type. Here, if you do include is equal to all, what it will do is, let me see. It will skip few mean for strings. It is skipping mean, max, and stuff, right? But if you include all is equal to no, this doesn't make sense on series. It will make sense more on pandas data frame. I ignore this for now. And now this is also the most useful one. Dot value count, series dot value counts. What this will do is it will return back a new series with index as the wait series dot c. Yeah. See, it will return back a new series where indexes are unique elements in the series and the values are their frequency. Here it is telling me that C is repeated 4 times, A is repeated 3 times, B is repeated 2 times, and E, G, H, and 1 are repeated 1 times. This is extremely important when we are working with something called categorical data or a series containing. Sometimes a series will only contain few categories like let's say employee type. Employee type can only be either junior, senior, or investor, something like this. Then what if I want to know how many juniors exist, how many seniors exist, and how many investors exist? All I should do is dot value counts, and it will return back return this distribution directly. Describe value counts, then unique. Yeah, is ser dot unique. It will just return back the number of unique elements in our series. Oh no, this is returning back the all the unique elements in our series back as a list. This is not truly a list like object. If you want to convert into a list, you should wrap list around it. Whenever you see something that looks like a list but it has any other type, you can directly try wrapping list around it and it will work just fine. See here, the moment I saw, it looks like a list, right? But it is telling me that they did a string array or something, and this might look scary. In such cases, all you have to do is just wrap a list around it and everything will work just fine. Then unique, yes, that's it. In this section, describe value counts and unique. General methods. Okay. from everything starts from here. You should there is no other way, but you have to by heart this. Here series dot sort values, sort data based on their value. This is quite easy to understand. Sort index, arrange sort elements based on index. Like you might ask, what does this mean? Series C here. Okay, let me give it a random index. Here these, if you see the index is sorted, right? 0 to 9, 0 to 17, 16. Let me try to sort it. Values, sort values. See, here it sorted me back the data. It sorted based on data A, B, B by increasing order, and you can control the order in here. Ascending, no order. Does it, what does it expose? Let me see. Sort values in ascending order. Hmm. Sequence axis, yes, ascending. If you want, they by default this will be ascending order. If you want to make it a descending, you can make this flag false. Ascending is equal to false. But now my point is you understood sort values, right? It will sort a data based on sort the series based on its data. But sort index is identical to it. Will sort the series based on index. Here, if you see the index is random, right? Wait, ID error. B. No, this is sorted to begin with. Hmm. Let me create a new one. PD dot series. Okay. I created a series with random characters in it, and in the see, this is how it looks. Now, when I try to sort it, it will arrange all of them on. Here, I am just showing characters, but you can store complete strings in them. See? D. Okay, fine then. After sorting, this is also resetting the index. If you see here, it is sorting them and resetting the index. I expected the index to be jumbled, but
No,
if the
no,
index,
SERC we
hmm?
mentioned. SER only, no, we created. The series name we given.
Yes, thank you. Good. See, it sorted the data, but the index is jumbled, right? What if you want to sort the index to? Let's say you have an sorted index to behave an series with index jumbled up and down, top and bottom. If you want to sort it based on index, then you should just use sort index. See, here the index is sorted and the data is jumbled up. When you sort values, data will be sorted and index will be jumbled. Is that clear on how sort values and sort index behave? Good. Then ser.reset index. What this does is it will discard the existing index and will assign an 0 to n minus 1 values to it. It will discard the index and assign 0 to n minus 1. You won't see this direct index. Hmm. Drop. Hmm. Did I write a drop? No, right? There is set index. I think in your notebooks you will be missing this. So I will attach the latest notebook, use this instead. And a drop duplicates. This is more easy to understand. If you have duplicated elements in a series, all you have to do is src series name dot drop duplicates, and it will drop every duplicated value. See here, there are too many duplicates in my above series, but here it only dropped the duplicates and only kept the unique ones. Then dropna and fillna. These are also easy to understand. Dropna and fillna are used to either drop null values. Here, what if your series has nulls in them? Pd dot series. Let me create a new one. 1, 2, null. No, not none. None. See, if you have a series like this, okay, let me make it all numbers. This is a series containing numbers, but it has a few nuns in it. Few null or none, both mean the same. But see, it has a few nuns in it, but some methods that we discuss later do not tolerate nuns in the data. I mean, there should not be nuns. Then you end up with two options: either replace none with an value or drop the elements which are none. Here, drop na will drop directly all the elements that are none. Series dot drop na will drop all the none values from the series and will return back a new series, and you should store it in a variable. Similarly, fillna will fill the nulls, replace the nulls in our series with the value we mention. Here, let me mention, I want to replace null with 0. See, here the nulls are replaced with 0. They are quite easy to understand. Dropna will just drop the nulls from your series, and fillna will replace nulls with the value you mention in the series. When you are dealing with a series of numbers, I think most of the times you will replace nulls with zeros. And if your use case needs another value, otherwise you should mention that value. But when you are working with strings, you will replace nulls with empty string. This more or less. Drop duplicates is clear. Fillna is clear. Okay, and drop and copy labels and index. I think copy should be clear, right? If you want to make if you want to copy a series is more or less an object, right? So you cannot do this directly. Series B is equal to series, and then if you modify series B, series A will also get affected, just like how a dictionary or list would. So you have to first copy it. Series B is equal to series A dot copy. Then it will work just fine. And now drop. What if you specifically want to drop few labels from the series? Here our series has what is our series storing? Okay, our series is storing 0, 2, 3, and 4, right? What if I want to drop labels 2 and 3? This is where the drop method comes in. Here it will take two attributes, either labels, or, and if you want to drop indexes, you should mention indexes. If you want to drop labels based on labels, you should mention those labels. 2 and 3. Let's see, label BELS. Okay. See, it dropped those labels and returned back a new series. Now, what if I want to drop an indexes? Index. Here I am asking it to drop 2 and I think 2 and 3. This does the same because in our case the labels and index are wait. Okay, this will confuse you. Up until now we have told that labels and index are the same thing, right? But in this method the index means position. Labels are equal to index in pandas, but this method is quite tricky. Here labels and index mean different things. Here index means position and labels means the actual key associated with the series. If you are having trouble understanding this, just ignore it. If you want to drop something by a position, Just think that you write index in rather than writing position. Okay, is this clear? Were you able to understand what I am trying to emphasize here? Is there anyone who doesn't understand this? Okay, fine. And series dot append and series dot concat. Hmm. Here series dot append will take another here scr dot append, and it takes a few more series, right? Series 1, series. Here there are 4 series in total. What this does, it pulls all the data from them and will return back a new series. Series dot append series C will raise an error because their data types doesn't match, or attribute error pd dot append. No. Let's see. Series contains nulls. What does series 1 contain? Series 1 is numbers. Series 2 is also numbers. Okay, so series 1 dot is it deprecated. Okay. ed dot by my module pandas. Okay. See, this method is old. This was removed from pandas. So I removed it too. And concat. pd dot concat. This will take a list of series objects and it will return back a concated version of it. It will pull their objects, pull their data. Let me print them side by side. Series 1 has A, B, C, right? And then what does series 2 has? B, C, and D. Now A, B, C, B, C, D. See, A, B, C, and B, C, D. If you see, the index is duplicated since Pandas supports duplicate series supports duplicated index too. When you end up with such situation, this is where the index resetting will come into picture. If you want to reset the index, you will just do reset index drop is equal to true. See, the we pulled the data from both the series and also resetted the index. Okay, with that we concluded the general method section, and there is no way around this. You have to you can technically forget the method name, but you should know that we can sort them, drop duplicates, replace duplicates, drop based on indexes, and drop based on position. We can reset index, we can sort based on values, or we can sort based on index, and we can even pull multiple series together using the concat function. And now the numeric methods. These methods are exclusive only to series containing numeric data, and these are very easy to understand. We will just go over them directly. Series dot min, it will return back the minimum value in our series. Series dot max value, mean, it will calculate the average and return back the mean. Mode means the most frequent element. If we have numbers, if we have a series of numbers, then the dot mode will return back the number which is repeated most number of times in our series. And standard deviation and variance, if you know what it means, fine. If you doesn't know, just ignore them. Dot power, series dot power. What does this do is raise the power of each element to 2. Series dot power. If you can, series 1 dot power 3 or 2 or anything. You can even do this, right? Even this works, I think. Yeah. Even this will work. Here, you can either use dot power, just like in our math module, we have something called power function, and we also have power operator. We can use either of them, right? So even in our series, we can either use this directly, or we can use dot power method. And then dot round. If you have floats in your series, like in our case, series one, what the series one has? Here the series one has integers, right? What does series have? Yes. Here our series has floats in it. But here let me create a new one. Et dot series 1.111, 2.222, 3.333. Take a look at this series. Here, there are too many decimals, right? What if you want to truncate or remove the number of decimals in your series? Then you just use round and mention the up to how many decimals should we round that number to. Here I mentioned 2, right? So it will only retrieve back 2 decimals and it will ignore the rest. If you see, this is called rounding. What do you mean by that? Series plot 1. See here, this is not truncation but rounding. Here we have 6660, right? When I round it, if you remember the rounding principles from math classes, since it is 6, it is rounding it to 7. Since it is 4, it is just rounding it to 4. I think this should be clear. I think we also have something called a truncate too. Do we have this? Yeah, we even have truncate. Wait, truncate to 2 decimals. This is a useful for Boolean indexing based truncate a series before and after some index value. Okay. This truncate is different. Ignore it for now. Just remember that round will take an integer value, and it will that value is nothing but the number of decimals up to which we have to round it. If you want to remove every decimal, we could mention 0. See, there are no decimals anymore. Good. These are, as I said, the general methods, the methods to understand shape, the methods to understand data, and the methods to understand general methods. The 3 categories of methods work on series storing any type of data, but these numeric methods will only work on series storing only integers or floats. If you try to use them on a series storing some other data type, it can either give us null value back, or it can raise an error. Let's see. I think it will raise an error. Series, what the series C has? Okay. Here the series C is storing strings, right? Let me try to ask min from it. Good. It is not throwing an error, but it is returning back mean value. See, their behavior changes. So you should not use them on series storing other types of data. You should only use them on integers or floats. Else, their result doesn't make any sense. Then string methods. These are exclusively on series storing strings. And these are quite easy to understand too. You already know that on a regular string, we can use lower, upper, and strip, and so on, right? Let's say if we have a string, just a string, we can use lower, upper. Every method that exists on a regular Python string also exists on Pandas series storing strings. All we have to do is first mention .str and then mention our string name, our method name. And here I only included the most frequent ones. You can even search for, there are so many methods. See, there are numeric, I think even is numeric exist. Dot. Okay, auto completion is not working. Dot lower. What this does it will lower every element in our series. Okay, they are already lowercase, right? Let me make it upper. Yes. Hmm. Every method that exists on a regular string will also exist on a string series storing strings, but the format differs slightly. You should first dot str and then you should mention the method name. Here, these are only the most frequent methods, but if you have some method in your mind, you can just check it out whether it works or not. Lower length strip contains replace. I think replace should be fine, right? Replace A in our string with replace B. Here you can even include substrings too. And Boolean methods. These only work on series storing Boolean values. Dot is na returns true for missing. Okay, is na, not na, is na, not na, is in, and between, right? Between A and B. Hmm. Oh, wait. Is na is nothing but is null. Not na is nothing but not null. When you do dot is na method on a series, it will return back a Boolean series with true or false, telling us that whether a value is an Boolean, whether a value is null or not. Let me see, where is our regular SCR? CR. I want nulls in them. Okay, where is this? Let me create any one. PD dot series none, none, 1, 2, 3, 4. Is na is like me asking whether is this value a null. If this is null, it returned true, right? The first elements are none, so it returned true. But for non-null values, it returned false. And not na is opposite of is na. It is asking, it is like me asking whether is this value in the series is not a null or not. Where I run this, see, this will be false and this will be true because these are not nulls, right? So they are giving us back true and these are giving us back false. You might ask, why should we use this is na and not na? See, what if I want to retrieve back only the elements that are not nulls in our from our series without dropping them using a drop na? In such case, we can do this. See, since series.notNav will return an series of booleans, we can directly use it for conditional filtering. See, it returned only back those values which are not nulls. This is where we can use them, and easing is quite easy to understand. If you want to check whether an element is within our mentioned elements, like series is nan 1 1 and 4, right? If I want to check whether is in A, B, or 1.0, 2.0. If I want to check whether an element is within a list of elements or not, we can use this method. It will return back trues. If the element is within this list, it will return back false if it is not. Here it is true. Why did it return true? Because one exists in our list, right? But all other elements does not exist in our list, so it flagged them false. Conditional filtering, we already covered this in our above sections. Date time methods. Just remember them. These are easy to understand. If you have a series storing date times, hmm, give me a minute. Okay, let's cover the rest tomorrow. The arithmetic operations, relational, logical, and then Iterating. Okay, fine. We will cover the list of this series tomorrow. After series, I think data frames should take less time. I think this series will take three classes. Pandas should just data frame should just take anywhere between 1 and 2 class. Since most of the methods we are covering them in series, right? So pandas will be very light. Data frame will be very light. Okay. Do you have any doubts related to today's class?
No, Tarun. I have to
Okay.
practice.
Yeah, fine.
Is series can have like
Mhm.
empty values also,
Okay, good. What do you mean by empty?
like nothing,
Yeah,
nothing.
nothing
And
null, right?
yeah,
They,
No, like some.
no, there is no concept of empty in any programming language. The moment you said empty, it is equal to null or none.
yeah, Tarun, we can replace it with a space, right?
Yeah, but
Yeah, that's what I'm saying. In
no,
Yeah,
string
no,
will
wait,
give
wait,
right empty
wait,
value.
wait. Not space. What you meant is this, right? A
Yeah, this
character
only.
without
yes,
anything, just
yeah,
an empty string.
Yeah,
yeah,
Yeah, this is not just my see, this is a problem too. What happens is users generally associate nulls with, you can associate null with zero, right? This is easier to
yeah,
understand. You can
correct.
associate an null with an empty string. This is not blank, empty string.
Yeah,
You can associate with nulls with empty string too, and you can even associate nulls with false sometimes. This is not a standard. Like in 100% of the cases, we cannot directly map nulls to zero or empty or the false. It depends on our use case. Sometimes in our use case, what happens is we have to preserve nulls. We cannot, okay, let me put it this way. Let's say we provided an user form. We asked user to type his name. User typed, if user didn't type anything, we will record it as null, right? But if user types just enters the cell and leaves it, it will be recorded as an empty string. There is a difference between both of them, right? None is not equal to empty string in that case.
correct.
This is just
okay.
user thinking that I want my username to be empty, not my username to be null. So there are cases where you can associate nulls with zero, empty, and false, but it depends on our use case. You should not 100% assume it. Based on your use case, you should replace them. And there is no such thing as empty. When you meant empty, it was a string with zero characters in it. Even this a string with a blank space in it, you should call that, because empty in a programming language can mean many things. So we should mention the exact data type. When you meant empty, what does it mean? Does it mean an zero, or does it mean a null, or does it mean an string with no characters in it? Okay, is that clear?
Yeah, clear.
And it is not always given that we should always replace nonce with zero, empties, or empty string or false. It depends on our use case. And I think we will cover that part too later in our PySpark classes. We will go over a section called data cleaning. And in that case, I will go over how we can handle nulls, like what should we do when we have nulls in our data, and we will go over various scenarios and then it will be clear. For now, nulls are just confusing. They are a pain in our neck. We don't know what to do with them, but just ignore them. We will discuss about strategies on how to handle them later. Okay, are there any other doubts beside this?
No.
No, Tarun. Yeah,
Okay.
yeah. Just want to know
Mhm.
the course curriculum. Like after this data frames, we'll skip to PySpark, right?
Yeah, I was told to cover PySpark for at least 3 to 4 classes, so
Okay.
we'll skim over it.
This
We will.
data frames and PySpark will be more or less similar, right?
Exactly. Not just a data frame for PySpark.
Mm.
Everything in data engineering is very, very boring. The concept will, yeah, exactly. The concepts in data engineering are extremely simple. Even if you see now, everything I am covering is more or less a form of SQL query in your SQL.
Correct.
Dot,
Yeah.
dot.
Yeah, only
Yeah,
syntax and
exactly.
keywords are different.
Yes.
Yeah,
Every concept will remain the same across SQL, pandas, data frames, or if let's say a new tool comes later, the concept will not change. The way how we write the keywords or the function names, attributes names will
correct.
change.
Yeah,
And this is the same with programming languages too. Now you know that a programming language contains data types, it contains conditional statements, it contains loops, and it contains functions, right? The moment you have a clarity on the structure of an programming language, you can directly go to another language too. Just the data types will change, and then the form on how loops and functions are written will change. Everything, the concept will remain the exactly same. People are generally afraid of writing code. They think that code is something alien to them and something that they couldn't understand. But for me, or I think code is just a way of expressing ourselves. Like let's say I want to eat something. You write in English, right? I want to eat something. It is made up of words and characters. Just like that, a programming language is nothing but a soup of data types and keywords. That's it. Once you understand the data types and once you understand the conditional statements, looping statements, and functions, there should be nothing you should be afraid of. I think most of the times what people do is they will watch something like lead code and stuff, and they
yeah,
think that competitive programming is the same as development. They are heavens and earth apart. Competitive programming is not at least 10% equal to development. In development, we can forget everything. See, even in my case, I sometimes forget methods from time to time.
yes,
Yes, we can do it. There is absolutely no problem. In development, what we should do is we should remember the concept, core concept. And then when we need the actual method or string, we should search for it and use it. But competitive programming is entirely different. But people will confuse that development is the same as competitive programming and will be scared of programming languages. Okay, fine
yeah,
then.
correct. And
Okay.
Tarun, you will be teaching this Databricks as well post PySpark.
See, Databricks is nothing but
PySpark returning in a Databricks portal.
exactly.
Yeah,
We will write PySpark in our Jupyter notebooks on our local machine. And what we will do is directly copy the notebook and paste it in a Databricks portal. That's it.
yeah,
But the only difference is that in case of local, when we write PySpark locally, our data is local. Like we will read data from our local files and work with it. But in case of PySpark, data can be anywhere. It can come from any source.
yes.
We work with that data and then process it. That's it. There is exactly no difference.
Yeah, Tarun, what I feel is we lag behind on how to pull the data via APIs and how to fetch the data from different sources, how to
Yeah.
integrate all those things. Once you are done with whatever curriculum, we'll do a kind of integration of multiple tools how we have in our real-time environments, right? So we'll go through that kind of use cases also, Tarun, once whenever you are free.
Yeah, see, what happens is, as data engineers, we are not expected to pull data. It might
Yeah.
sound very taunting that we should pull data from here, we should pull data from there, and so on.
Yeah,
But there are different types of data engineers. But I think what you are learning now is big data engineering, right?
yeah, correct.
And what you see out there is traditional data engineering. They are what we call ETL and ELT flow engineers. What they do is it is their task to pull data from various sources. And in our course, we are not even covering those tools. If you see,
Yes,
we
yes, we are not doing that. Uh, uh,
but
yeah.
don't worry. I will show you.
Just to show us one use case. See, this is the source data from where we
Yeah.
are pulling this, and as a data engineer, these are our tasks. And from here, we are keeping it in a warehouse, all the cleaned data or the manipulated data. So like that, if also real time, they will ask these kind of questions only. I was going through some kind of random interviews.
Yeah.
So I felt I don't have answer for those questions, whatever they are asking. These kind of real time, what is your source data? Can you explain from the data flow in your process? Like that. So I'm just checking with you. Will you be covering that?
Wait a
Yeah.
minute. Where is CDN? Yeah, not ADF. Give me a minute. Azure, Apache Spark. Okay, fine. See, I don't think uh, this
Yeah.
was the full course, but I was just told to introduce you to Spark and Databricks. I don't think
Okay.
I'm covering this, but I will be giving you the okay. I think I will do this. The project will be covered. I will
Mm.
cover the Spark in 1 or 2 days and then directly go to the project. I have a full project planned out for you. Like you,
Okay. Yeah. Yeah. That
I will
will
make you.
cover all the questions, I
Yes,
guess. Yeah.
I will make you set up your own blob storage, then put data into it, then fetch the data yourself, create integrations, then work with it, build a task, and so on too. And
Yeah.
I will even make you write your own pipeline. I will only show you a demo pipeline, and then you should write the pipeline on your own. Everything is here in here, but I don't think I will be covering in detail. But even if I don't cover it, I will
Yeah.
assign every document in this project to it.
Okay.
That is for sure.
Yeah. Yeah. Thank you, Taran. That will help. So we'll go through the.
Hmm.
Yeah.
Fine. Then, are there any other doubts, or can I end the class now?
No, no, you can end the class. Thank you
Fine.
for your extra time.
Fine, fine, fine.
Yeah.
Thank
Yeah, Taran. We'll catch up tomorrow.
you.
Yeah. Bye.